intense. That's how it goes.
3 minutes was shorter than you think it is.
3 minutes, it's enough to say what's the purpose, what's the problem you want to solve, how you're going to do it, and what does it take.
What you're looking at right now is the first schematic for a cure for the deadliest infectious disease known to humanity.
I talk a lot, so at different presentations I see myself running beyond time. So the participation has helped me learn how to carve my story and then present it in a pitch form in a very short time.
Thank you very much.
I really fell in love with this event because it brings together all the great minds on one stage.
You need to be also out of the box in order to share, to feed your own research with the contact with the others.
I hope that the future sees more collaborative efforts like this, where people come together, bring in different strengths, and fusing those together to solve complex problems. And science will be key to that journey.
Dear Falling Walls Lab Slovakia finalists, dear jury members, dear distinguished guests in the audience, welcome to the Falling Walls Lab Slovakia 2020 final. My name is Marian Holienka and I will guide you through today's ceremony. Now allow me to invite Professor Peter Moco, the president of Falling Walls Lab Slovakia, for his welcome and introductory address.
Dear finalists of the Falling Walls Lab Slovakia 2020, ladies and gentlemen, the fall of the Berlin Wall on the 9th of November 1989 was truly a breakthrough event in the world history. On the occasion of its 20th anniversary, quantum physicist Professor Jürgen Mlýnek organized in 2009 a unique worldwide gathering of young scientists and innovators, Falling Walls Lab. The Falling Walls Lab is nothing less than a prestigious worldwide platform on future breakthroughs in science and society. Young scientists and innovators have a unique opportunity to present their groundbreaking ideas in the attractive competitive format. There is always at least one Nobel Prize winner in the jury at the World Finale in Berlin. Slovakia joined the Falling Walls Lab in 2017 after the meeting of Professor Mlýnek with Professor Bužek and myself in Bratislava. In 2018, we were very successful with Falling Walls Lab Slovakia. Prime Minister Pellegrini personally attended the finale, and 2 young Slovak scientists got an opportunity to represent Slovakia in Berlin among 100 world finalists. We understand very well how important it is to support talented, diligent, and motivated young people. Without them, there is no future for our society, country, and nation. I want to thank you, our finalists, for your participation in this event despite the pandemic which prevented us from organizing a traditional finale at the Moises Hall. We very much appreciate your effort. Your contributions and presentations will be carefully and responsibly evaluated by the jury. Let me introduce its members in the alphabetical order. Professor Vladimír Bužek, academician of the Learned Society of Slovakia, Slovak Academy of Sciences, chairman of the jury. Professor Hornis Kausa, Max Gassmann, member of the German National Academy of Sciences Leopoldina from University of Zurich. Associate Professor Marian Holienka, Comenius University in Bratislava. Myself, I'm now president of the Learning Society of Slovakia, and I work at Comenius University in Bratislava. Professor Martina Muckenthaler, member of the German National Academy of Sciences Leopoldina, University of Heidelberg. Professor Silvia Pastoreková, academician of the Learning Society of Slovakia, Slovak Academy of Sciences, and finally Professor Peter Zvara, University of Southern Denmark. I want to thank all jury members for their kind help and contribution to our finale. I especially thank our distinguished foreign colleagues. I also thank members of the scientific committee, rectors Miroslav Fikar, Stanislav Kmeď, Jana Mojžišová, Pavol Sovák, and Marek Števček, president of the Slovak Academy of Sciences Pavol Šajgalík, and co-founder and CEO of Tachium, Radoslav Danilák. I would like to specially welcome precious guests to our virtual finale. Professor Jana Mojžišová, rector of the University of Veterinary Medicine and Pharmacy, Professor Pavol Sovák, rector of the Pavol Jozef Šafárik University, and Dr. Zuzana Veziak, representative of the German Academic Exchange Service. I hope I didn't miss any representative of major university, but I do not see any. Dear finalists, I'm looking forward to your presentations. I will keep my fingers crossed for you. Thank you for the attention.
Thank you very much for your welcome address and encouraging words to our finalists. Now, it is my great pleasure to announce our next welcome address. The Falling Walls Lab Slovakia has always enjoyed the support by the German Federal Foreign Office and DAAD, the German Academic Exchange Service. Therefore, we are very happy that the ambassador of the Federal Republic of Germany to Slovakia, Mrs. Barbara Wolf, sent her video address to our finalists and all event participants.
Hello, my name is Barbara Wolf and I'm the German ambassador to the Slovak Republic. The fall of the Berlin Wall 31 years ago became a symbol for the power of the individual, a symbol that positive change is possible. The Falling Walls Lab, which is among others supported by Germany, is transposing this positive symbol to the world of science. I would like to congratulate all Slovak participants in this year's final for taking part under challenging conditions of the corona pandemic and wish you all success. We need science, we need innovative and future-oriented science to overcome pandemic. We need it also for many other challenges like climate change. Thank you also to the Comenius University as a partner of the Falling Walls Lab. And once again, all success to you. Thank you.
Thank you very much, Mrs. Ambassador, for your supporting and encouraging words towards our event. And next, it is my great pleasure to announce that the Falling Walls Lab Slovakia 2020 is organized under the auspices of the Ministry of Education, Science, Research and Sport of the Slovak Republic. And we are thankful for this expression of support and recognition. Also, we are happy that Dr. Ludovít Paulis, the State Secretary of the Ministry of Education, Science, Research and Sport of the Slovak Republic, sent us his video address too.
Dear participants, dear organizers, dear guests. Over the last couple of decades, our society has been facing several challenges, such as the prevalent climate change, energy and food security, and currently the greatest challenge of all, the global pandemics of COVID-19. The brightest and most innovative among us are working hard to solve these global issues. Through their discoveries, science and innovation can bring us the desired solutions and reverse those negative trends. In order to be successful in this struggle, we need to create a supportive and motivating environment for scientists, innovators, and entrepreneurs. to provide them with opportunities, space, and the necessary resources, to give them a chance to present their original ideas and solutions, which might be groundbreaking and move us closer to our common goals. Youth is crucial for the future of science. At a time when many young people are leaving their homeland to pursue their studies abroad, support for talented young scientists via events like this presents a great opportunity to show that science and research in Slovakia are more important and reputable. The Falling Walls Lab Slovakia 2020 is a platform for you, young scientists, entrepreneurs, and professionals from all fields of expertise to present your research activities, business models, and innovative projects to a jury comprised of science and business experts. All of you, the national finalists, have already shown your talent and determination to work hard. Many of you also intend to continue to work at higher education institutions or special laboratories, or have chosen a noble calling which contributes to building a better future for all of us. Such work is worth our admiration and gratitude. I am immensely proud and glad that we are so fortunate to have a wealth of smart people in this country who do not hesitate to share their original solutions. The winner of today's national event will progress on to representing Slovakia at the World Finals in Berlin. I hope and wish that today's event will be full of inspiring presentations and discussions for everyone involved, and that you will all thoroughly enjoy the experience. Good luck to all of the competitors and much fun for others taking part. Let's make this a day to remember.
Thank you, Mr. State Secretary, for your really encouraging message and encouraging words. And now allow me to invite Professor Vladimír Bužek, the jury chairman of the Falling Walls Lab Slovakia, to deliver his welcome address and to introduce the evaluation criteria for today's presentations of our young innovators.
Good afternoon, everybody. So welcome in this virtual meeting, virtual finals of Falling Walls. It's really under very unusual circumstances. We sit here at the Comenius University, like in control room in Houston, and I hope not to hear like a message, Houston, we have a problem during this meeting. So far, so good. So let me introduce, since the jury already been introduced by Professor Mozzo, I just introduce very, very briefly the criteria according to which the jury will evaluate your presentations and your work. So there are like three criteria. The first one is the breakthrough factor, and it's the most, it's a criteria with the highest weight, up to 50%, it's 50%. And essentially it's about, as usual, it's excellence. It's about originality of the project, whether there's really something that is groundbreaking and whether one can expect science to technology breakthrough out of your idea. The second score, the second criteria, which is weighted by 30%, is the relevance and impact of your work. So whom you are going what is your audience for your result, whether the idea of yours will affect large group, a broad group of users at the end of your, whether it's a long-term impact of your research. And finally, as usual, even though none of us been trained as an actor and presenter, we are supposed also to present our results in a sort of attractive form. So therefore, there is a criterion, which is a performance and structure, how you structured your presentation, how you've been able to really to deliver the main ideas, because it's really challenging to have just 3 minutes. It's like an elevator pitch. You have, in 3 minutes, you have to compress everything you want to deliver, and you want to impress the jury and obviously the general audience. So we have the three criteria: breakthrough factor, relevance impact, and structure and performance. They are weighted by 50%, 30%, and 20%. And finally, the scale on which we score these criteria is from 0 to 5. 5 is the highest score, and obviously 0 is the lowest score. So with this, I believe we have all the scoring criteria announced. And now I pass the word back to Marian Holienka, who will inform you about the details of your presentations. Thank you.
Thank you, Professor Bužek, for your welcome and for explaining the Falling Walls Lab Slovakia approach to evaluation and explaining the criteria. And now, allow me to move to the part of today's event we are all most excited about. Our finalists are going to present their innovative ideas in short 3-minute pitches. Let me remind you that they will be streamed from the pre-recorded video presentations. However, our finalists and jury members are present online, so the streaming will be followed by a short live Q&A session. Some questions were prepared by our jury members in advance, and you will see them on the screen during the Q&A session. The session itself should not exceed the 2-minute limit, and the time will be watched. I will guide you, of course, during the Q&A. I will read the questions, and your brief answers should follow. If there is any following question, the jury members and also the audience members are invited to step in, but please keep in mind that the time limit is very short, so we need short questions, short answers. And this is the art of presenting the innovative ideas. As for the presentations, they will follow in an alphabetical order by the surnames of the finalists. So first, it is my pleasure to announce a presentation of Matej Balaš from Slovak Academy of Sciences, who is going to present his idea that breaks the wall of solution-based chemistry.
Dear colleagues, it's a big pleasure for me to show you how it's possible to break down the wall of solution-based chemistry. Green synthesis of silver nanoparticles is a topic which is very well researched these days. The principle is in the production of extract by using various biological organisms and combining it with silver nitrate solution, and we end up with silver nanoparticles with various shapes and sizes. However, this process has some disadvantages. So at first it's multi-step one. We need usually higher temperature, and in case of some biological organisms like lichens, their reducing species are insoluble in water. In another story of traditional chemistry, PVC waste is usually incinerated. However, toxic dioxins are formed, TCDD being the most important representative, and Ukrainian President Yushchenko was actually poisoned exactly by this compound. In the classical inorganic synthesis of nanoparticles, the authors usually use organic precursors, or at least they use organic solvents, and it's also a multi-step process, and usually higher temperatures are necessary, so we end up with the same disadvantages as shown before. This all can be really nicely targeted by using solid-state approach called mechanochemistry, applying tools of ball milling. In the case of silver nanoparticles, it's possible to directly include the biological organism into the milling chamber together with the silver nitrate powder, or we can also do it with eggshell membrane or Oreganum vulgare plant, and at the end we have composite from silver nanoparticles and residual matrix, which usually has antibacterial activity. So it's one-step process, solvent-free, the products are quite stable, and it's possible also in the case where it was not possible in the traditional synthesis. The other examples of mechanochemistry are, for example, dechlorination of PVC waste, where we can also take another waste, eggshell, which is source of calcium, and this calcium reacts with chlorine to form calcium chloride, which is harmless compound, and this has also been proven to be working with the industrial waste, which is window parapet. The dechlorination was almost complete. In solvent-free synthesis of nanomaterials, it's possible just to directly mill powders together, and we get in one step the final product. Mechanochemistry can be applied in various different fields, and this is my message: how to break down the wall of solution-based chemistry using mechanochemistry.
Thank you, Maciej, for your presentation. And now let's move to the Q&A.
Okay, so can the process be used for an extract? Yes. I'm sorry. Okay, now I see the question. So I am supposed to react onto this question now. Yes. Okay, so in the first case, of course, it's possible for a whole periodical table of elements. There are many reports using also organic chemistry, also main group elements, and the industrial scale. Actually, it's also possible by using some technologies. It is possible, for example, twin screw extrusion is something which is very good way how to scale up mechanochemistry, or we also have some experience with performing experiments at least on 100-gram or kilogram scale in eccentric vibratory mill. So there are more technologies which are scalable. How far is it from industry application? Well, actually, I am also taking part in European COST project, where the title is Mechanochemistry for Sustainable Industry. And actually, this is exactly the topic of one of the working groups. So I think the application is not very far now. I guess it would be in, let's say, 5 years, but there are already, I know, some companies which really use mechanochemistry or solid-state ball milling for the production of materials that are applied for various fields of science, like pharmacy or for example, synthesizing the material which is used in cars.
Thank you. Are there any other questions from the jury panel or guests, please?
Yes, I would have one. This is Max Gassman. Thank you very much for the presentation. I have to be fast. So what's a uniqueness? What's so unique about your ideas compared to what is done already by others?
The main point is the way how we synthesize materials. So it's really solvent-free, waste-free, and scalable option, how to use also not only synthetic chemicals, but also how to recycle waste materials, for example, for example, in my presentation I have shown I combined 2 waste materials to get something useful out of it.
Good, thank you.
Thank you, Maciej. The time for your quick Q&A is over. So I thank you for your presentation and for your answers. And we will skip to our next presenter. The next presenter is Katarina Chakiova from Technical University of Košice, and she will present her idea how to break the wall of aesthetics and function in architecture.
Good afternoon, my name is Katarina Chakiova and I'm from Technical University of Košice. Today I will be speaking about breaking the wall of aesthetic and function in architecture. But first, imagine that you live close to the forest, with a lot of greenery, maybe close to the river or lake. It's nice imagination, but the reality is quite different, and most of us live in the cities. So what we do in contemporary architecture is that we use different nature elements, like green roofs, walls, but also water features, for example, water walls. These decorative elements can bring peace of nature inside the buildings. But the question is aesthetic value enough in sustainable architecture? I think no. So the main motto of my work is transmission from aesthetic to function. So the object of my research is water wall, and I want to show its effective use. First, I identified the parameters of the indoor environment that can be affected by the water wall. I decide to focus on thermal comfort, mainly to air temperature and humidity. What I want is to use the water wall for dehumidification or humidification of indoor air by two physical processes, condensation or evaporation. I choose experimental verification under laboratory conditions in climate chamber. For the testing, I made experimental water wall prototype and install set of sensors inside the chamber. For each process was made different measuring system based weighting of condensate or evaporation in time. Also, it's necessary to say that the water temperature in the system is controlled and falling water film is in direct contact with air. I made 30 measurements with different boundary conditions. The next step was data analysis that brings the possibility to quantify the water wall as a device and describe its dehumidification or humidification capacity by equation. Equation shows that dehumidification and humidification potential is a dynamic process that occurs from boundary conditions. The goal is not to replace the traditional air conditioning systems. I know that it's not possible, but the goal is to combine them with the aesthetic water feature to reduce the energy consumption of the buildings. Thank you for your attention, and if you have any question, please ask me.
Thank you, Katarina, for your presentation, and let's move to the Q&A. The questions will be also visible on slide.
So first one, I can't compare these two systems because if you can have a lot of different typical air conditioning systems. My idea was to use this element which is already in interior with some function. So for example, in the case of dehumidification, the capacity was the maximum capacity which I measured was 300 grams per hour when the humidity was 85% and temperature 27 degrees. So the idea is combine the water feature with traditional systems. I can't compare the energy consumptions.
Katarina, before you proceed to the second question, maybe the other members of the jury can ask a question. And if I just invite other members of the jury to ask questions, not only those that are, okay, so somebody's, Peter Zvara, okay.
Peter Zvara, I have a question. What does the 300 grams an hour mean in a regular size room? How much of a dehumidification can you provide? That would be my question. I can imagine that you can humidify, but how does the condensation dehumidify? How effective is it?
It depends from the volume of room. It depends from the furniture, or a lot of different things. This is the main point why I define the water wall as device. So if you have bigger room, the effect will be smaller. If the room will be smaller, the effect will be bigger. So I quantified water wall like device with equation. This was the idea, main idea why I made this kind of experiment and this one.
Okay, thank you. And one brief question from Professor Muckenthaler.
Okay.
As your hand is raised.
So how would you put your idea into practice?
How you can show few examples of water wall which already exist. So this water wall is element which exists. My idea is control the water temperature. In my case, I use for the cooling of water, well water, and the temperature was around 14 degrees. So it already exists, just we need control the temperature of water, but it already exists like element.
Thank you.
Okay, thank you very much, Katarina, for your presentation and for your answers. And now we are ready to skip to the next presentation, which will be delivered by Aaron Hortobágy from Technical University in Zvolen, and he will introduce his project which breaks the wall of chainmail rings production.
Good afternoon. I'm Hortobágy Aaron from Technical University in Zvolen in Slovakia. Today, I would like to introduce you to the idea I have been working on, and it is the breaking of the wall of the chainmail rings production. There are several ways of making chainmail fabric, which are usually classified by how rings are interconnected and by how are individual rings closed into one piece. Ends of the ring can be touching loosely, such rings are called butted, or they can be fixed by a rivet or by a welt. Our wall stands by production of riveted rings, which are mostly used by groups of historical reenactors. Armor from such material is sturdy enough to withstand strikes from cold weapons, and it closely resembles its historical predecessors. Some enthusiasts choose to craft their own armor from scratch. First step, which is coiling of wire, can be automated very easily. Afterwards comes cutting of coil into the rings, which is not hard to do, but with requirement of several thousands of rings, this process quickly becomes wearisome. For butted rings, it is enough to run the coil through some kind of cutter and the whole coil is processed at once. But with the riveted rings, ends of wire have to overlap, and this solution cannot be used. So the wall that I want to break is to make an easy way to further automate production of riveted rings and make it quite simple and affordable for either individuals or small groups of historical reenactors. I have chosen to address this challenge by changing the way how the wire is usually coiled and by adding a cutting mechanism into the process. This way, coiling stops each time when enough wire is bent at the end, and the end of the coil is cut into the ring with overlapping ends. Then the ring slides on the rod into the container and awaits next operations. This setup is mostly meant as a guideline for people who would rather create their own device, so it is meant to be as simple as possible. While it is still more complicated than the device for coiling alone, once made, it will require less interaction from human. It is only needed to put the wire into the holder, and the device will be able to run unattended, which will save a lot of production time and of course a lot of sores on the hands from cutting of thousands of rings. So far, I would like to thank you for your attention, and I hope that I will be able to help with anything if there's something unclear about my presentation. Thank you very much.
Thank you, Aaron, for your presentation. And we skip to the Q&A while we start answering these two questions, which are basically the same in nature. I invite the other jury members to prepare their questions if they have any. So now, Aaron, please tell us how far is this from industry application and whether it can be used in producing something else except of what you have shown us.
Hello, so far this is only the model and actual working model is being worked on. And as for the other applications, chainmail is usually up to today used by, usually in an industry where there's some kind of cutting. For example, in meat processing, there are gloves of chainmail, and they are used as a protection against knives. Also, some kind of chainmail is used as divers from, and also I have made chainmail decoration product.
Thank you for answers. And do we have any other questions from the jury or in the audience? If there are no questions, then thank you very much, and we are going to skip to the next presenter, who is Filip Humeník of University of Veterinary Medicine and Pharmacy in Košice, and he will present his idea how to break the wall of stem cells therapy.
Good afternoon, ladies and gentlemen. Let me introduce. My name is Filip Humeník. I am PhD student at the University of Veterinary Medicine and Pharmacy in Košice. I would like to explain our problem of stem cell therapy. There is a lot of pathological conditions connected with impaired vascularization, like red gone, bone healing, stayed after heart attack, stroke, or spinal cord injury. Stem cells can improve regeneration capacity of soft tissue, hard tissue, or organs in failure situation. However, there is a lot of limitation of application of stem cells, as are donors availability, age of donors, immune response of recipient, because application of stem cells could be characterized like transplantation. But there is a solution of this problem, and it is application of mesenchymal stem cells products contained in conditioned media, as we showed in our study. First of all, we isolated mesenchymal stem cells from bone marrow of healthy dogs and characterized obtained cell population to fulfill the criteria of International Society for Stem Cell Research. It means morphology, multilineage potential, and presence of surface marker typical for mesenchymal stem cells. Next, we obtained 24 hours conditioned media and analyzed it via proteomic study to know its composition. To confirm our hypothesis that mesenchymal stem cells products improve angiogenesis, we used cow model of chicken embryo and applied 50 microliters of conditioned media on its surface in experimental group and 50 microliters of new media in control group. After 72 hours of incubation, we found out increase of vascular density about 75% by comparison in control group. This result were confirmed by gene expression analysis of chorioallantoic membrane from all two groups. We found out upregulation of 10 genes in experimental group, which supports angiogenesis and vascularization. Thank you for your attention.
Thank you, Filip, very much for your presentation, and also let's skip to the Q&A session. So you can see on the slide the questions from the jury. Please, could you reply and explain us how innovative is the aspect of your approach to MSC-mediated therapy compared to the established MSC-mediated approaches? And this is also the second question, which is more or less the same. So please, the floor is yours.
Okay, so good afternoon, ladies and gentlemen. So in my opinion, it is innovative because I don't know that somebody in this country or in this area use conditioned media as well for therapy. We know that there was something like using of new therapy. It means Habenport in last time. However, the Habenport is synthetic therapeutics used in this area. So I think that something which was made from stem cells as they are, there is no concentration. I think that is more naturally, yeah, because if we use the Habenport, I think there is a higher concentration of these growing factors and others markers or something like that than in this in our study.
Thank you, Filip. Any from the other jury members or from the audience? Okay, yes, please.
I apologize. It's Peter also. So what's the point to take something from animals, from dogs, for curing humans? Why it is not possible to take it from humans?
Yeah, it's possible to take from humans. However, I'm PhD student at the University of Veterinary Medicine, so I orientated to veterinary patient. Yeah, and we have dogs as the most important patient in a small practice.
Okay, because you showed human legs.
Human legs, because there is a small amount of pictures from veterinary medicine of bed-gone wound healing.
Okay.
Okay, Philip, thank you very much. And now it's time to speak to the next presenter, who is Alexander Karutsenko from Technical University of Košice, and he will present us his idea how to break the wall of car accident.
Good afternoon, my name is Alexander Karutsenko. Today I would like to present you the topic which will expose the main problems of car accident. The number of accidents in the world is growing. There were 1 million of people who died in car accidents during 2010 year. There are 2 million of victims who passed away within the past year. 5 million people got physical disabilities because of car accident in 2010 years. And by the end of 2019 there were 10 million. It is difficult to imagine how many deaths and accidents will be in 10 years, given that the amount of accidents has grown twice by this time. It's much more than victims of various epidemic diseases, anti-terrorist operations, some wars, accidents in manufacturing, home, etc. And for some reason nobody pays such attention to the problem of car accidents as to other equally important issues. Today I want to share my opinion on solving this problem. If you choose any 100 road catastrophes at random, then in 99 cases it will be a problem of humans factor. Someone is tired at home, someone detained at work, someone fought with his wife, and someone is drunk and not willing to walk home from a nightclub. It is very difficult to find a solution for this problem, but despite all the facts, our world progresses all the time. Technologies are developing. Therefore are much more opportunities. Progressive autopilot is autopilot that would manage a car 100% on its own. A person will not be able to interfere with the management of a device. Cars will communicate with each other using the internet. Accident will become barely possible. It will be like a public transport or taxi. Only taxi is yours and there is robot instead of a driver. This kind of car will not be able to go faster than 50 kilometers per hour, will not cross the crossroads of streets to red, won't be able to knock down a man, and will not choose a destination. Everything you have to do is to input the destination and intermediate locations which you want to stop in. Not only main disadvantages of a modern car will be gone, but there will be more advantages. Cars will be able to move people with disabilities, people who are under 18 years of age, traffic jams will disappear, emissions in the atmosphere will gradually decrease, science robot autopilot will be incredibly economical and environmentally friendly. Thank you for your attention.
Thank you very much for introducing your innovative idea, Alexander. And now is the time for Q&A. So please tell us, what is the most distinct feature of your approach compared to the other approach? And what is your own contribution to this idea?
Hi. I started with second question. I study technology of automobile production. I have a car in home. I used this technology in my car. Started use technology in my car. Also, I working with my bachelor's work in terms autopilot. First question. What is the most?
So in other words, how is your idea unique? And how is your idea original?
This is an original idea. This is hybrid idea. None of the people have done it yet. They made a machine, but this was unfortunate concept. They use technology of smart vacuum cleaner. My technology is to use data, other cars, and people. It's like atoms that never touch each other.
Thank you. Any questions from the jury or from the audience?
Yes, perhaps I can ask the question. So because it was difficult for me to understand. So for example, is not Tesla and other cars already using very similar technology, or are you completely with something new?
Okay. Tesla use technology for help people is in driving. I use technology for autopilot drive in on 100% for car. People don't drive car because 99% of car accident begin for people factor. It's I'm sorry, my English is very bad.
No, it's fine. I think we understand and you answered the question well, and it's time to finish the Q&A session as the time is over and we need to skip to the next presentation. So thank you, Alexander. And the next presentation will be from a different field delivered by Klaudia Kyselicová of Comenius University in Bratislava, who will tell us something about breaking the wall of autism screening tools.
Good afternoon, everyone. This presentation will address autism diagnostics. According to the Centers for Disease Control and Prevention, 1 in 54 people have autism or at least some form of autism, and the numbers are still rising. We can't stop it, we can't prevent it. The only thing we can do about it is diagnose it early enough and start psychological treatment. The problem is it can be diagnosed only by a psychological assessment of the child's behavior. But if the child is 1, 2, or 3 years old, this typical behavior, the autistic behavior, does not always have to be present in a child. I work at the Academic Research Center for Autism, and according to our statistics, almost 10% of cases remain undiagnosed before the age of 5. And these children don't get proper help early enough. If a child doesn't get a behavioral therapy early enough, it faces more difficulties in life than a child that was successfully diagnosed at the first attempt. So, what can we do about it? Well, we have proof that fingerprints of an autistic person differ from the fingerprints of a neurotypical person. We found that autistic people have more ulnar loops, they have less whorls, and they have more dentate arches. While the dentate arc occurred only in autistic people, not in neurotypical people. Based on this, we can already predict the probability with which a person is at risk of having autism or developing autism. This can easily turn into a diagnostic tool. Imagine, it takes only your mobile device, like your phone, which has a camera. All you need to do is take a picture of each of your fingers, then answer some questions regarding your gender and background, and that's it. Within seconds, the neuronal network within the mobile application compares your biological data with a reference database and gives you a risk assessment. There is no doubt that this is reliable because fingerprints don't change throughout life. It is quick, it is accessible, it can be applied before any autistic behavior occurs, and it is definitely user-friendly. After this, you still should go for a psychological assessment, but now, as a parent of a child, you would probably go with much more confidence. Imagine what a difference this would make if 2% of the world's population could get a risk assessment just by taking a finger selfie. Thank you very much.
Thank you, Claudia, for introducing your project. And we skip to the Q&A, but before we focus on the questions prepared here, do we have any live question from the audience or from the jury? We do have one.
I have a question, Peter Moco. Is it really your original finding that there is some relationship between autism and fingerprint? I think I have heard about this relation before, but I'm not sure.
Well, it is known that there is a relationship between neurodevelopmental disorders such as autism and different fingerprints. But by so far, I don't know of any study which would give you a direct risk assessment by which an individual has autism. This may answer the first question. We made a study which was based on 1,500 fingerprints of autistic children, and we have made a risk assessment for these children, also looking at the behavioral traits. And we found a lot of significant differences. These differences were really such great that we decided to make a statistical prediction model for this.
Okay, thank you.
Yeah, we have a question from Professor Muckenthaler and then Professor Zvara, please.
So my question relates to the first question also noted here on the file. I was just wondering, with which specificity do you detect autism disorders by the fingerprint? So you said you analyzed 1,500 patients, I just heard. And so what is your specificity in this analysis?
We didn't look for the specificity because for now we looked just for a way to predict it from fingerprints. We were looking for 8 different patterns. So we used a widened classification that was used in previous studies, and therefore we found more differences than previous studies did. We looked for these differences in 1,500 fingerprints. So this is the basic of this work. And now regarding neurological disorders, of course, people with other neurological disorders have these differences as well, but other differences. The major fact is that these people all differ in the IQ. And we used a sample of children which had normal and even over average IQ and were autistic. So this is the major difference, that fingerprints not only relate to neurological disorders, but also to the IQ of the individual.
Thank you, Claudia. And a short question from Professor Zvara, and your short answer, please.
So you said that you had 1,500 patients, and you also said that all the autistic children have tented arches, while the neurotypical individuals don't. How many in numbers did you see this observation of tented arches in each group? And was there an exception?
In these 1,500 fingerprints, we saw tented arches in approximately 1/2 of the autistic sample, and they occurred only in the right hand. This was the interesting part, that they occurred only in the right hand and not in the left hand. And compared to the controls, there was just one boy who had a tented arc.
Thank you.
Yes, and another thing is that they occurred only in the little finger. This is the major difference, that you have also to look not only at the frequency, but also on the location of these patterns.
Okay, sorry for stepping in. I believe there is a lot to talk about with your project, but we need to move further. And I would like to welcome Michal Takac from Technical University of Košice, and we are going to listen to his presentation on how to break the wall of learning mathematics.
Hi, My name is Michal Takáč, and I'm a PhD student at the Technical University of Košice in Slovakia. And in this presentation, I'm going to try to break the wall of learning mathematics. So throughout the primary and secondary schools, mathematics is taught in a formal way, focusing on abstract representations, moving symbols around in equations, and memorization of procedures. This approach then presents real problems at the university mathematics because students have problems creating mental models that would allow them then to apply their knowledge to solving real engineering problems. I'm breaking the wall of learning mathematics with a project called Math World VR, an immersive learning environment in virtual reality in which students break from the traditional way of first methodically learning how to shift symbols around in equations and then trying to understand how this exercise translates into graphical representation, often missing the connections, point of the idea or concept that the teacher wants to express along the way in the lecture. With this project, I'm trying to take traditional approach and turn it on its head. So instead, students dive into this immersive world that embodies change. At first, they are encouraged to play with the graphical representation of some mathematical concept, to try changing things, see how things on the screen behave according to the change they made. They are encouraged to ask questions why? Why is it behaving like this? Why I can't have input x past some number? Why it changes so quickly or so slowly? And so on. They are able to touch, grab, zoom in, zoom out, and interactively update inputs or boundary conditions. And then with real-time feedback, equations, graphs, visualizations, or in the future even simulations of real-world problems respond. Seeing this responsiveness first and then supporting it with the formalization of mathematical concept helps to build up deeper understanding. The prototype you see is actually running in a Chrome web browser without the need of installing additional plugins, and it can be accessed from high-end VR headsets, mobile VR headsets, desktops, or even smartphones. It uses WebVR technology, and the code is open source. Math World was also mentioned at the Google I/O live event in Mountain View, California, to showcase what WebVR in Chrome browser is capable of. And in a closing note, I want to say that the world we live in is not static. It's dynamic. Things move, flow, spread, behave in particular ways. They change. And mathematics can describe phenomena like this. But if we want to get our students, future engineers, to understand this message, we have to stop adding bricks to this wall. So thank you for your time.
Thank you very much, Michal, for showcasing your project. And let's move to the Q&A. So the first question is that whether the hypothesis behind your approach is that the visualization concepts can be better understood, and if you have any quantitative data from students or from any user statistics and user feedback, if I merge it with the second question.
Okay, so the first thing is we see how our students at the Technical University of Košice are doing at the tests, at the exams on the mathematics, and they often have a problem reaching certain degrees, or the trend is going downwards. After we introduced the new ways of teaching mathematics, and we get our students to try VR and mathematics in VR, they are starting to be more motivated to learn about the concepts, and with this approach, the test scores are starting to get up again. So we are in the process of gathering this user statistics, and we are going to publish the results.
Thank you for answering the question. And we have a question from Professor Gassman.
Yeah, one question I really also fascinating about this possibility to learn mathematics. My question is, have you been trying to approach this also for lower school, like elementary school, primary school, because this has a commercial potential what you have there?
First, we need to fix the way how the university translates the mathematics teaching into then getting our students to understand the engineering problems and then apply the mathematics to solve the engineering problems. But there's definitely a way to use this at the primary or secondary schools if you want it. And as I mentioned, the method VR can be used at the multiple of platforms. So you don't even need to use VR in the first place. You can also look into it or use it from just your desktop or smartphone. So, yeah.
Okay,
there are possibilities.
A question from I have one question. One of the best mathematicians in Slovakia told me that he cannot work out very abstract ideas without visualizing them in his mind. So this looks fantastic to me and really with big impact for anybody in the world. Is it really fully original or there is some competition for this?
I think there is a competition. The competition in a way that the other projects are trying to focus mainly on VR platforms. So they want to get you to use high-end VR headsets to see this immersive world. My approach is to take this into open world, use open source technologies, use web browsers, and make this technology accessible.
Thank you, Michal. And a short question from Professor Zvara.
Have you thought about intellectual property protection? In other words, have you submitted or think of submitting a patent?
No, I didn't think about that yet.
Thank you.
Okay, short question, short answer, and your time is over for the Q&A. So, Michal, thank you very much. And last but not least, we are going to the final presentation of today, which is going to be delivered by Zuzana Vikartovska from University of Veterinary Medicine and Pharmacy in Košice, who will tell us something about breaking the wall of canine cognitive dysfunction.
Hi everyone. I would like to present you how we want to break the wall of canine cognitive dysfunction syndrome in University of Veterinary Medicine and Pharmacy in Košice. Canine cognitive dysfunction syndrome is progressive neurodegenerative disorder of aging dogs older than 8 years. Its clinical signs include alteration in social interaction. So that means interaction between pet owner or another pet, disorientation, anxiety, alteration in sleep-wake cycle. Its pathology is very similar to Alzheimer's disease in humans, so it means thickening of the cerebral cortex, enlargement of the ventricles. Its pathology also includes accumulation of amyloid beta peptide in cortex and activation of microglia. This is a very underdiagnosed disease in veterinary medicine, as most owners consider this clinical sign as a normal aging process. Currently, we have no treatment available for this disorder. Our solution lies in using mesenchymal stem cells with their immunomodulatory and paracrine effect, what means they act to stimulate the patient's cells to repair the damaged tissue. They have also anti-inflammatory effect. They are able to support formation of the new neurons and differentiation and proliferation of the neurons. What is more important, from human studies, we know they are able to reduce accumulation of amyloid beta peptide in the cortex and they are also able to stop neural apoptosis. With all these characteristics, they seem to be a very good candidate for a possible treatment of canine cognitive dysfunction syndrome with potential translation also into human medicine. Thank you for your attention.
Thank you, Zuzana, for your presentation. And it's time to skip to the Q&A. So you can see the 3 questions. Please tell us something about describing the modern side of MSc implantation. If you have any experimental proof supporting your idea, and what is the advantage of implantation MSCs compared to MSC-derived exosomes? And then we skip to the next questions.
Okay, thank you for your questions. So first of all, we already did clinical studies, but it was on the spinal cord injury. It's in the dog. It's also published. And we used the conditioned media, so the products of the mesenchymal stem cells, with the improvement of the neural system. Also, I agreed that the exosomes are a also very good candidate. Actually, we are working now on how to apply these exosomes to our therapy. For the second question, yes, there are also many animals that have cognitive disorders, also for the cats. But in our university, the most patients suffering from the disease are the dogs. So we're using now dogs, but of course we can use it also for the cats and other animals. The clinical studies were done, experimental studies, were done also on the rats and mouses. Well, actually, for the first question, we're pretty close to clinical testing, as we have stratified the patients suffering from this disorder, mild cognitive dysfunction, and now we are working on starting the clinical testing.
Thank you for your answers. And do we have any other questions from the jury or audience? Well, if not, we are just on time, so your Q&A session is over. Thank you, Zuzana. And we are done with the presentations for today. So, dear participants, jury members, distinguished guests in the audience, we have seen all 8 presentations, and it was an exciting experience and a truly multidisciplinary experience. And now it is time for our jury to do their job. They will leave this online meeting and switch to another private meeting where they will decide about the winners of today. So welcome again, dear finalists, dear participants, and dear distinguished guests. Now it's time to announce the winners of the Falling Walls Lab Slovakia 2020. First, let me invite Professor Vladimír Bužek, the jury chairman of the Falling Walls Lab Slovakia 2020, to start the award ceremony.
So thank you, Maria. So first of all, as they usually say, everybody who took part in this competition is a winner, especially this year when we are working in a very challenging environment. On the top of everything, we have these technical issues to be resolved, and all of you, both finalists and the members of the jury, made fantastic job thanks to the technical team behind the scene. So all and everybody here is a winner. Now, the jury had a very hard work to specify essentially the order of the first 3 laureates of this competition. We really had a discussion, very thorough discussion. However, at the end of the day, of the meeting, we've been able to find a consensus, so to say, on the ordered list of the first 3 winners of the competition. And it's a pleasure to pass the word to the president of the Falling Walls Slovakia, Professor Peter Moco, who will make the announcement of this competition.
Thank you. I absolutely agree with jury chairman, Professor Bužek, that we had an exciting presentation session, and based on this exciting presentation session, we had almost the same level of excitement during discussions in jury decision making, but we really were able to find conclusions. The third place, Matej Baláš, Slovak Academy of Sciences, breaking the wall of solution-based chemistry. Congratulations, Matej. The second place, Klaudia Kyselicová, Comenius University in Bratislava, breaking the wall of autism screening tools. Congratulations, Klaudia. The first place, Michal Takáč, Technical University of Košice, breaking the wall of learning mathematics. Thank you, 3 winners. Thank you, everybody who really in this pandemic took courage and had sufficient enthusiasm to attend, to prepare presentation, and to let us have this opportunity to enjoy this afternoon meeting in Falling Walls Lab Slovakia finale. So dear all finalists and 3 winners, thank you very much. Now I will pass the floor to Dr. Zuzana Weziak, representative of the German Academic Exchange Service, which is traditional supporter of the Falling Walls Lab and specifically Falling Walls Lab Slovakia. Thank you.
Thank you and good afternoon or evening already. Yeah, in real, I would now have the pleasure to hand over the prize for the winner. Today, let me just say a few words on behalf of the DAD, which is supporting the Falling Wall event financially. I would like to thank everyone who took part in this event. Regardless of the difficult conditions, I am very happy that we managed to make it happen. I would like especially thank to the team who planned and organized the event, the technical support, and of course the jury and the researching students who presented their ideas today in a very innovative and enthusiastic way. The past few years, the winner usually traveled to Berlin to the finals. However, this year, due to the COVID-19, we will create a professional video of the pitch, which can be used afterwards for its own purposes. And we think this brings additional benefit for the winner. Furthermore, all finalists will receive a small DAD present by post in the next days. Thank you very much and all the best.
Thank you, Zuzana, for your congratulations, and also from my side, from the master of the ceremony, I would like to thank to all participants, all finalists, or all jury members, and last but not least, all the distinguished guests who attended this event today. Our today's event has come to its end. Just to remind you and just to mention, to add to what Zuzana from DAD said, the winner of today's final of the Falling Walls Lab Slovakia actually also wins a spot in an international final of the competition, the Falling Walls Breakthrough of the Year in the category Emerging Talents, where this professional video that will be prepared by our team and edited by the Falling Walls global team will be posted among another videos of winners from international labs who will create a group of 100 international young innovators and researchers. And among these, an international or global jury will select 10 global finalists. So our winner has a chance to even go further, to present his idea on an international stage and to win a place in an international final. So we will all wish him the best luck with this. And I will remind, or I will require Michal to remain connected to the call for some technical details at the end. And now it's time to say thank you again, and time to say goodbye, and a time to invite you cordially already for the next edition of the Falling Walls Lab Slovakia, which we will be really excited to prepare in the future. So I hope you will follow us also in the next years, and I wish you a nice rest of the day and goodbye. Thank you.